Hi, everyone, and welcome. Have you ever been listening to tech news or just in a conversation? In terms like artificial intelligence, machine learning, deep learning, they all just get sort of tossed around, almost like they mean the same thing. It can definitely get confusing.
Oh, absolutely. It happens all the time.
So today we're going to try and cut through that confusion. Our mission here is to break down these concepts using the great source materials you shared with us. Okay, let's unpack this.
Yeah, let's do it. Because what's fascinating and I think really important is that while these terms are definitely related, they're not the same. They actually describe different, distinct levels of technology. Understanding the sort of hierarchy there is just key to, really getting a handle on the modern tech world.
Right, it stops you getting lost in all the buzzwords.
Exactly. So this deep dive should give you that clarity, that solid foundation.
Okay, so AI, artificial intelligence. Lots of people just use AI as this big catch-all term, don't they? But our sources, they draw a clearer line. Let's start there. What's the real big picture goal of AI, according to what we've read?
Right. AI is the old idea, the broadest vision. It's really the ambition to create machines capable of tasks that normally need human intelligence.
Okay, like what kind of tasks?
Well, think big. Problem solving, learning from experience, perception, seeing and hearing, and even understanding natural language like we're doing now. It's about aiming for that human-like cognition. And your sources pointed to some classic examples, right? Like early expert systems, robotics, those computers that play chess or Go.
Got it. So AI is the grand goal. But what was the big problem early on? What stopped them from just making intelligent machines right away? This is where machine learning comes in, isn't it?
That's a great question. And yeah, the huge hurdle was how you actually made the machine smart. Early AI involved programmers trying to write down every single rule for every possible situation.
Wow, that sounds impossible for complex stuff.
It pretty much was. That's why machine learning, or ML, was such a breakthrough. It flipped the script. Instead of explicit programming for every step, ML allows systems to learn from data on their own. They find patterns, they make predictions, and they improve over time without someone coding every specific instruction. It's a fundamental shift.
Okay, that makes sense. So it's learning how to do the task from examples.
Exactly. And we see it everywhere now. The materials mention things like, your spam filter, learning what's junk, streaming sites recommending what you might like, banks spotting weird transactions. That's all ML working behind the scenes. It's the engine that learns from data.
It really is everywhere when you think about it. You mentioned banks spotting fraud. Did the sources mention any other, maybe less obvious examples where ML really showed its power early on?
Yeah, actually, one interesting area highlighted was medical diagnosis. ML algorithms started spotting really subtle patterns in things like x-rays or patient records, patterns that even experienced doctors might miss sometimes.
Leading to earlier detection.
Potentially, yeah. It really demonstrated the power of finding those hidden connections in data.
Okay, so AI is the big goal. ML is a way to get there by learning from data.
Yeah.
Now let's drill down even further to deep learning. DL. This is a type of ML, right? But what makes it special?
It is. Deep learning is a specific and very powerful subset of machine learning. The key difference is its use of something called artificial neural networks.
Neural networks, okay. Like the brain.
Sort of inspired by the brain, yeah. But the deep part means these networks have many layers stacked on top of each other, lots of layers.
And why are the layers important?
Because they allow the network to learn features in a hierarchy. So the first layer might learn simple things, like edges in an image. The next layer combines those edges into shapes. The next combines shapes into objects. It builds up complexity.
I see, like understanding builds piece by piece.
Exactly. And this hierarchical learning lets DL tackle incredibly complex tasks, things that were really out of reach before. Think about the examples in the sources. Image recognition that lets self-driving cars see, or the speech recognition in your phone's assistant, understanding what you're saying, or those chatbots that can have surprisingly natural conversations. That's often deep learning at work. It's like an advanced ML engine for really complex patterns.
So putting it all together for everyone listening, how does this all stack up? It feels a bit like one of those Russian nesting dolls, doesn't it?
That's actually a great analogy. Our sources basically confirm that. AI is the biggest doll, the overall goal of intelligent machines.
Okay.
Then inside that, you've got machine learning, a specific approach to achieve AI by learning from data.
Right.
And then inside ML, you have deep learning, a powerful technique within ML that uses those deep neural networks for complex tasks.
So AI, ML, DL?
Precisely. And, Understanding this isn't just academic.
Yeah.
When terms get misused, it really affects how people understand progress, maybe how companies get funding. It matters.
Yeah, that's a really good point. So knowing AI is the vision, ML is the learning engine, and DL is the advanced deep layered engine that gives you a much clearer lens to view things through.
It really does. And maybe this raises a final thought or a question for you to ponder. How does knowing these distinctions actually empower you? Well, for one, it lets you look at headlines about, AI breakthroughs or AI dangers more critically. Is it really general AI they're talking about, or specific advance in ML or DL?
Right, separating the hype from the reality.
Exactly. It helps you understand the difference between the long-term aspiration and the actual capabilities being developed now. It just gives you a much sharper, more informed way to think about how these incredible technologies are evolving and, well, how they'll continue to shape our world.
That's a perfect place to leave it. A more informed perspective is always valuable. We really hope this deep dive helped clarify these often muddled terms for you and maybe spark some more curiosity. Thanks so much for joining us for this exploration.